sure you understand every single part of this before we even begin teaching the material, okay? So, it's called, Lecture 2021, it's called Higher Degree Inequalities. Now, we need to figure out what is the goal for this particular section. What is the goal? Okay, so are you ready?
No.
Here's the goal. Find the interval. The goal is to find the interval. By the way, I'm recording. Had a couple people absent last hour and I forgot to record it. So find the interval. What does it mean when I put in a parenthesis with an S by it?
It means it can be plural, but it's not always plural.
Very good. It can be singular and it can be plural, either one. So find the interval or intervals that satisfy the inequality. Now, when I say inequality, and I have to condition this, when I say inequality in math class, what am I referring to? What things should come to mind when you hear the word inequality?
Things that aren't equal.
Things that aren't equal, okay? Give me 4 symbols that you're looking for.
Add.
No.
Oh.
No. Yes, what are those called? He went like this.
I don't know what they're called.
Oh, is it like the greater than, less
Yes.
than, equal to?
So less than, greater than, less than equal to, greater than equal to. So we're looking for things that are less than or equal to, or greater than or equal to, or less than or greater than. Okay? So we're going to find the intervals that satisfy the inequality. Okay, now, I thought there was something else there. Oh, so here's what we're looking for. We're going to give you we're going to start off with polynomials. We're actually going to give you rationals later on. A polynomial is going to look something like this. Right? So polynomial function. Something like that. Now when we said, and we've been doing this forever, when we say find the roots, it would be like this polynomial f of x equals 0. Equals 0. Find the roots. What are we looking for? When we take a quadratic and we find the roots, or take a cubic and find the roots, what are we finding? Omar, you look like you had an answer.
Oh no, it's still right.
Okay. And your graph does not have to look like mine. I just go to sketch that in there.
Well, it does.
Okay. What am I looking for when I say find where it equals, find the roots?
X.
X what?
Intercept.
X-intercepts. Very good. So I'm finding the x-intercepts right here. I'm finding where does it cross the x-intercept. So rather than using equals, we're going to use an inequality like greater than or less than. In that case, what do you suppose we're looking for? If equals tells me I'm finding the x-intercepts, what do you suppose a greater than sign or a less than sign would refer to?
The y-intercepts?
No. Last hour said the exact same thing.
Because the way you set up the question, that's what
Right.
makes it.
What do you suppose?
What do you suppose?
Last hour got it. No pressure.
Come on. I'm feeling the pressure. Come on.
You need me to repeat the question?
Now I know the question.
Inequality.
Let me repeat the question. If x equals 0 is the equality, and that's where we're finding the x-intercepts, what do you suppose would mean if I'm saying like f of x greater than 0? What would that be?
0?
Say it again.
Are you finding 0?
We've already found the zeros in equal to.
The other number? I don't know.
What numbers would be greater than 0?
Oh, positive.
All the positives. So I'm looking for all of these values up here. I'm looking for the interval of values that are above the x-axis. What if it was f of x is less than 0? What would I be looking for?
Below?
The intervals of the values that are below. I'm looking for these values down here. I'm looking for an interval from here to there, from A to B. Okay, I'm looking for those intervals where all the numbers are above the x-axis if it's greater than, or below the x-axis if it's less than. So that's my goal. That's what I'm looking for.
Is the greater than or equal to 0 the same?
The only thing difference between greater than and greater than or equal to is if it's equal to, it would include the value.
Okay.
If it's not gonna, it's not actually gonna change our process at all. It's gonna change one little bracket versus parentheses. That's all it's gonna change. Good afternoon. Okay? So, do you understand what we're looking for? We're looking for values that are above the x-axis or below the x-axis of some polynomial. Okay?
Wait,
For what?
so I can mark this?
All right. How's it going?
Going alright.
Class good this morning?
Mm-hmm.
Good. You good?
Yeah.
Okay. So then, I'm going to do some notation here. And this is going to be kind of a chart, just kind of help. You've seen all this before, this little chart, but I just want to put it together. Okay, so the first thing I'm going to do is I'm going to make a shape. And I'm going to make an oval right here. And then I'm going to make another oval over here. Let's make this one, though, let's make it dotted. Let's make it orange.
Are we making
That gives me orange, that gives me blue. Okay. Say what?
Do we make the ovals?
I wouldn't make them. It's kind of a little cheat sheet, little chart thing. You probably know everything already. If not, this is helpful. Now, I did make it dotted on purpose. So you want to make one dotted and one solid. Okay. Now, we have two different types of intervals, because remember my answer is going to be an interval. Are you good?
Can I just take a picture of the slide before?
Yes. Oops. There we go. Suck in the gut. Whenever you take a picture, suck in the gut. Okay, there we go. All right, so there's two different, remember our answer is going to be an interval or intervals, correct?
Yeah.
So in our intervals, we have two different types of intervals. One of them is called open. Take a guess. What's the other one called?
Close.
Closed. Outstanding. Now, closed is going to be a solid line. Open is going to be the dotted line. So whenever we make dotted lines for open, or we make lines for open, it's going to be dotted, closed is going to be solid. Now, with open, is that going to be less than and greater than, or is that going to be less than equal to, greater than equal to? Open functions.
I feel like, wouldn't it be greater than or equal to?
No.
No.
It's going to be greater than or less than. So closed are actually going to have the equal to signs. Okay? Now here's one everyone's going to get the answer to, just by listening, okay? If I put a circle on a graph, and it's open or closed, would the circle be open, or would it be closed?
It would be open.
Good, very good. So over here, if I put a circle, it's going to be an open circle. On the closed, if I put a circle, it's going to be closed or filled in.
Bless you.
Thanks. What is
Okay,
it?
very good.
Okay.
Okay. Now, when I go to abbreviate an interval or notate an interval, if it's open, do I use parentheses or brackets?
Parentheses.
Use parentheses.
It's making a face.
I was like, oh. Don't hesitate.
I did this on accident once, and I've been doing it like this ever since.
Oh.
So on closed, what am I going to make?
Bracket.
Make brackets. Very good. And he's like, oh. Do you see the face?
I
No.
do.
And if you would like
That's
to
why I
add
said it
ears,
was
you
on
know,
face. My
and
ears are really tiny.
maybe hair, curly hair. This is the extent of my art ability, by the way. Just so you know,
Yeah.
this is it.
I think it should go in blue.
I'm gonna go and get rid of that because that's kind of embarrassing. Okay, it's like Mr. Potato Head. Okay, so we got open and closed. Are we good?
Sure.
Sure? You good?
Yes.
Good, good, good. Okay,
Yes.
now, my first example is gonna be very simplistic. Remember we said this is higher degree, right? So like third power, fourth power, fifth power. We're gonna start with a very basic second degree function, a parabola, to make this very easy to work through the process, okay? Then we'll do an example of more difficult, more challenging. Okay, so, let's see if I can copy this down correctly. I copied it in the wrong last hour. So example number 1. X squared minus x minus 30 is greater than 0. Start off with a very basic parabola, make life easy for it. And for those of you who like steps, I'm gonna kind of walk through what our steps are over here. So number one, you really should make sure it's in standard form. Refresh our memory, what is standard form?
A squared, ax squared, bx, and c.
Okay, so everything to one side, 0 to the other, and they're in descending order. X squared, x, constant. Standard form. So when I give you your homework, there's gonna be several that are not gonna be in standard form. So the first thing is distribute, move everything to one side, do all your basic algebra. It's not that hard.
That's just my favorite email.
I'm sure it is. Number two. Now, the second thing we should probably do is, in order to find out where it's positive and where it's negative, we have to find out where does it cross. Find the zero. Let's find the zeros. Where is it going to go from negative to positive? Where are the barriers at? So the first thing we have to do is find the zeros. So we've been doing that for years, right? This is a quadratic. How do I find the zeros of a quadratic?
You have to do the thing where it's like you have to split it up, or like you have to flow it out where it's like x times x and then whatever adds and then whatever.
I think you're trying to say factor it.
Yeah.
Yes. You could use the quadratic formula. You could use complete the square. Most of the ones we do are going to be able to be factored. So let's factor it. Okay? So let's go ahead and factor. What is the factor to?
Splits it up.
So now I'm going to have x and x. What are the two numbers? Excuse me.
1 and 30?
1 and 30 would not add to equal and
Wait,
negative
it
1.
Oh,
would be
never
like,
mind.
I forgot you had to do that too. 6 and 5.
6 and 5. Which one's negative?
6.
-6.
-6, +5. Beautiful. So then we factored it, so then we know in our heads then what are the two zeros at?
6 and -5.
6 and -5. That's the two zeros. Okay, that's the two places that equal 0. So then we know no other places is 0. So then we kind of know where it's going to change from a positive to a negative or negative to positive.
Right.
Okay, so number 3. We're going to create a number line. Now, remember when you were in elementary and you made your number lines and you had to do a 0 in the middle and then 1, 2, 3, 4, 5 and -1, -2, -3? We don't do that. We're in college algebra. We're going to make a number line.
Yeah.
We know where the numbers should be, right? We know zeros in the middle, positive to the right, negative to the left. So I'm just going to sketch on here about where the numbers are. So over here to the left is going to be -5. Where is 6 going to be relative to that?
Like almost exactly on the other side.
Yeah, it's going to be the other side, somewhere over here. I can make it wherever, as long as it's to the right, as long as they're in order. Okay, if you put them out of order, then that's your issue. Okay, so just put 2 points on the number line. Sometimes you'll have 3, sometimes you'll have 4, whatever. Sometimes you'll only have 1. Put your points on the number line. Okay. Now let's go ahead and break this into intervals. Do I have an open interval or a closed interval?
You have it open
How do you know?
because it's greater than.
Greater than, so we know it's going to be open. So I'm going to go ahead and put my open circles and dotted line right here, and I'm going to break my number line up into 3 segments.
Oh, I don't have a good one for all that.
Okay. Now I have my 3 sections. I've got this section over here, and below -5, between -5 and 6, and above 6. So I've got my 3 sections. Now I know that every point in between -5 and 6 is going to be exactly the same sign. Okay? Because I cross here, these are the zeros. Okay? So everything in here is either going to be above or below the x-axis. Does that make sense? You're not going to get a negative and a positive. They're either all going to be all below or they're all going to be all above. Okay? Because there's no other way to get from positive to negative without crossing through 0. All right? So then, all I have to do is test 1 point. If I can just find 1 point, pick 1 point, any point in there, it'll tell me whether all the signs are positive or all the signs are negative. So let's pick a point between -5 and 6. This is number 4. Pick a test point.
4.
Okay,
Wait,
you could
no.
use 4 because that's between the 2. I could also pick
3.
3. I could pick -2. Since 0 is in between here, 0 is going to be the easiest number, so I'm going to pick 0. Okay. But you can legitimately pick any number because they will all give you the exact same sign. I could pick negative 4.9 or I could pick negative 5.99, doesn't matter. Okay, any number between. Okay, so I'm gonna take that test point, that 0, and I'm gonna plug it into my, this is a problem we had last hour. Some people got confused on this one. So I'm just gonna take that 0 and plug it into these two functions. So what is 0 minus 6? Negative 6. What is 0 plus 5?
5.
5. That's why it's the easiest, because it's just the number, right? Now, if I multiply these two things together like they're being multiplied, what's negative 6 times 5? Negative 3. And all I need to know is the sign. So because it's negative, that means that every value between negative 5 and 6 will result in a negative value. Every number between negative 5 and 6 will give us a negative value. You can check another one if you want. Plug 1, 2, 3, 4, 5, whatever. They will all be negative. Okay? So let's take a test point over here. I just always go one away. So if this is negative 5, I'm going to use negative 6. You confused on something?
Yeah.
What are you confused about?
Why is it only negative?
Well, when I plugged in 0, that gave me negative 6 times 5, which is a negative value.
Oh,
So every value in between these will be negative.
okay.
Doesn't matter what point you use.
Even the positive 6, it will be negative?
Well, no. If I put in 6, it's going to be 0. But if I put in a positive 5, x equals 5, what's 5 minus 6? Negative 1. What's 5 plus 5?
10.
And what's a negative 1 times a 10?
Negative 10.
It's negative. Doesn't matter what value you put in, they will always be negative. Okay? That's why we call it a test point, because every value will make the same sign, and I just need to know is it negative or is it positive.
Okay.
So over here, let's use negative 6. Let's plug in negative 6. What's negative 6 minus 6? Negative 12.
Oops.
What's negative 6 plus 5?
Negative 1.
Negative 1. So what is negative 12 times negative 1? I just need to know what sign it is.
Positive.
It's positive. 2 negatives make a positive, right? So that means whatever value I put in below negative 5, every one of them will be positive values. Okay, they'll all be above the x-axis. Everything here will be below the x-axis. Let's take a test point over here. What value should we use?
8.
8. Beautiful.
Stop being basic.
Okay, plug it in. 8 minus 6 gives me
2.
2. 8 plus 5 gives me 13. Am I going to have a negative or a positive?
Positive.
Notice I don't even have to know the number. I just need to know if it's the sign, what's negative and positive. Oh, bless me. So positive. Okay? Now, someone's going to say later, do they always alternate, like positive, negative, positive? A lot of times they do, but I drew an example over here where it's negative, positive, positive, positive. Okay, so you need to check and test every single section. Okay? Now, what am I looking for as far as answers? What interval? Am I looking for the positives? Or am I looking for the negatives? And how do you know?
Negatives.
So test the point, number 5, determine the interval. Okay, and you said we're looking for what?
Negative.
Why are we looking for negatives?
Because it's less than? I don't know, I just guessed.
What's that
Is
say?
Is that greater than?
That's greater than.
Okay, I don't know the difference. I don't know.
Okay, so this shape here, if you turn it, it's an L.
Oh.
So that's less than.
Okay.
Less than. So in this case, this is not less than, it doesn't look like an L, so it's
So
going
it's
to
greater
be
than-
greater than. So which ones am I looking for, the positives or negatives? What's greater than 0?
Positive.
Positive. So I'm looking for this interval over here. So if I write this interval, it's going to be negative infinity to negative 5. Is negative 5 going to be a bracket or a parenthesis?
Negative 5?
Uh-huh.
It's going to be a bracket.
Why?
Because you stop there, anything after that is negative.
Do you agree?
Well, I thought since it was open, I thought it was parentheses.
It's open.
Oh, okay.
Remember, it's open here? So because it's open, it's a
Okay,
parenthesis.
cool.
Go back to your sign. If it's a parenthesis, everything's going to be, or if it's a less
Well,
than
I
or
just
greater
thought
than.
that because it was just going to stop.
But the problem is it's not including negative 5. Negative 5 is not part of the answer. negative 5, if I put negative 5, I equal 0, that's not greater than 0. So it's going to be a parenthesis. And that's part of the reason why we do the open and the dotted. That right there will tell you if it's a parenthesis or a bracket. Okay, but it's also over here, correct?
Yeah.
What's this interval over here?
It would be 8.
No.
It would be 6.
6 to
Positive infinity.
infinity. And those are both going to be parentheses as well. And then the u just means you add them together. So my answer is negative infinity to negative 5 and 6 to infinity. Any value you pick that's between negative infinity and negative 5, or that's between 6 and positive, any number you pick will give you a positive value. Will give you something that's greater than 0. There you go. 5 steps. Standard form, zeros, number line, test point, determine the interval.
Oh, thanks.
Got it?
Yep.
Process makes sense.
Yep.
Yeah.
Let's do one that's a little more difficult.
Great.
Same exact 5 steps. X cubed, example number 2. X cubed, and I already forgot what it was, is greater than 10x minus 3x squared. I believe that's the correct problem. There we go.
Alright. X cubed.
Hopefully that'll give me enough room. X cubed greater than 10x minus 3x squared. All right, what's the first thing we do?
Standard form.
How do I do that?
Make just move everything over, so like negative 10x and then positive 3x squared.
And make sure you put it in descending order, right?
Uh-huh.
So I'm going to have x cubed plus 3x squared minus 10x. Doing any of that, adding and subtracting those things over, does that change my sign?
No.
No. I still have greater than, and on this side there's nothing, so it's greater than 0. Now, what does that greater than tell me? It tells me a couple things.
Open.
It's going to be open, which means I'm going to have everything is parentheses. Okay? And then it also says greater than, so I'm looking for what?
Positive.
Positive answers. Okay. All right. So let's go. We did standard form. Number 2, we have to find the zeros. So how do I factor this? First thing with factoring is always what's in common. So what do they all have in common?
X.
X. So let's take out an X. All right. And then it factors to what?
5 and 2.
One of them has to be negative. Which one's negative?
The 2.
Bam. X plus 5. And X minus 2. Very good. Number 3. Are we good so far? I'm just going to sort of truck along. There's a small class, so the question just stop. Stop. Did I say trunk? Truck along?
I don't know what
I
he's
think you
Just gonna
can
move.
truckle along.
Truck along? Yeah, that's what I'm, just truck along, just move. Just
Wait, okay, but the other one was,
No, I'm gonna
we're
stop.
looking for positive, and then there was only 1 or 2 positive numbers in the answer.
2 intervals. Correct. So, okay, so let's pause for a second since you brought that up. Let's go and see if I can, let me see here. Is it up here? Boom, okay. So what you've just proven, and the thing is we could always do it on a graph, but we want to prove it. So algebraically we prove it. So what was the function? X squared
Minus x minus 30.
minus x minus 30, right?
And then greater than 0.
Okay, so what you just did was, if we graphed the function, we just found that it's above the graph, negative infinity to negative 5, and it's above the graph, 6 to infinity. That's what we just found. And that's what we just proved.
Okay.
We did it algebraically. So you can always go onto the graph and check it. Okay, what's above the x-axis and what's below. But to algebraically prove it is what we're doing. Okay? So that being said, let's jump back to here. Okay, so where are my zeros at? Because that's what we're finding. We're finding our zeros. Where are our zeros at?
5 and positive 2.
Say it again.
Negative 5 and positive 2.
And there's one more.
What?
And 0, right?
because x is by itself,
Yeah.
so x could also be 0 there. So now I have 3 points that I'm gonna have to graph, okay?
One of those trees. Oh my gosh, that's so cool.
Okay. Sorry, I had to make more room. Okay, so make a number line. Now, I will tell you that I've had kids on a test do this. They put, oh, well, this must be -5, this must be 2, and this must be 0. I've had kids do that. What's wrong with that?
Not spacing.
They're stupid.
Don't worry about the
That's what's
spacing.
wrong.
No,
Two.
your students are a little bit.
They weren't thinking, they were going quick, and they weren't, wait a second, I have to have it in numerical order, okay? 2 does not come to the left of 0, okay? Did you just say it doesn't? Did you really just, anyway.
No, I was doing-
So 0 has to go next, and then +2 over here. And I'm not real worried about the spacing. I'm worried about what order they go in.
I am.
You're worried about the spacing?
Yeah.
Then you might want to put little dots in
I'm
there.
joking.
Let's make that a little bit neater.
Yeah.
You know what? I'm gonna even get fancy for this class.
Get
Watch out,
fancy.
guys.
Here you go, look at this. It's a straight line, look at
Whoa.
that. Boom.
It's still
That's
not.
so
it's
bad.
Still not
Is it
straight.
crooked?
Yes.
It's a bit crooked.
Okay, from where I'm standing, it looks straight.
You made it worse. Okay.
Oh.
There you go, there you go.
Right there?
It's better.
It's
Yes.
Close enough, we're gonna have to deal with it, okay. So I'm gonna have -5 over here. I'm gonna have 0 somewhere here. This looks like it's going downhill.
It is
Okay, I'm not going crazy then. Okay, so then what type of lines am I gonna put on there?
dotted.
Dotted and open circles, right?
Yeah,
Open,
if you feel like it.
dotted, open. I should've just stuck my first one, cause this is just as bad as that one. Okay, so we've got all the intervals. And there's 4 intervals this time, right? 4 intervals, here, 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 and there. Okay, so pick your test points. What test points should I use over here?
-6.
-6. Okay? So I'm gonna put, and this time, rather than actually coming up with the numbers, I'm just coming up with the signs. If I put -6 in here, it's gonna be a negative. And then I went ahead and put the number. It's gonna be a negative. If I put -6 plus 5, what's that gonna be?
-1.
-1, so that's gonna be a negative. If I do -6 minus 2, that's gonna be -8, so that's gonna be a negative. What do 3 negatives make?
A negative.
Negative times a negative times a negative is a negative.
Yes.
Woo!
So there's a negative. Okay. All right, pick a point between -5 and 0.
I
Negative
thought we
4.
multiplied them.
No, you subtract, or you do whatever the sign is.
You actually do multiply. Negative times a negative times a negative. You actually multiply. But I'm not worried about what the number is, I'm just worried about the sign.
She's talking about like each individual interval. Like what you do with the -6, so like -6 and then -5,
No.
right?
I'm not confused. No, nothing. I think I just read it wrong.
Okay, so let's see if we can clear it up on this one. What point am I gonna use between -5 and 0?
-4.
-3.
Okay, I heard -4 and -3, let's use -2. Okay, doesn't matter what number you use, as long as it's in between them. So we plug it in here. If I plug in -2 here, I'm gonna get we can just actually put in -2. What's a -2 plus 5?
3.
+3. What's a -2 minus 2? -4. Now when I take a negative times a positive times a negative,
Positive.
I get a positive. I don't care the fact it's 24, it doesn't matter. The fact that it's positive is what I need. Can you tell me again why? Why am I worried about what that sign is? What does that tell me?
That's one of our intervals, our answers.
Okay, it's going to be, but what else does that tell us about it? What does it tell me about every single value in here?
It's all positive.
Every one of them is positive. Every one of them is above the x-axis. What point do I use in here?
1.
X equals 1 between 0 and 2. Could I use 1.5? Sure. Could I use 0.3? Absolutely. What we're gonna use 1. So what do I get? I'm gonna get a +1 times a +6 times a -1. So what's that interval? What is it?
Negative.
It's all negative. Negative times, or positive times a negative is negative.
Okay, so when the numbers, like for -6, you subtract it from the intervals,
Okay over there?
Yeah.
and then
Yeah.
there's like a positive, like one you add it to
Are you
the
excited for
intervals.
this?
No, I just plug it in. So what's, this is going to be -6, right?
There you are.
Mhm.
So you just plug it in. What's -6 plus 5?
We'll go.
-1. You just plug it in
Oh.
and do the
Yeah.
math.
Oh, you plug it in where the x is.
Correct.
Okay.
That's because x equals, so -6 minus 2 is
Where's that number going?
-8. Now, I don't, once again, I don't need to do the numbers, but if that helps you, do the numbers. But remember, all I'm looking for is the sign. It's called a sign chart, so I just need to know the signs.
Ah,
What test point will I use over here? X equals what?
4.
27.
I can use 4. I'm not going to use 27 because that's way too.
Come on.
So x equals 4. So here I would have 4 times 9 times 2. And once again, we do have one.
-2?
I'm sorry?
It wouldn't be -2?
4 minus 2.
Oh,
It's okay.
yeah. Sorry, still
Alright.
getting it.
You're fine.
Don't forget your crown.
So once again, this one is all going to be alternating. Now, once again, I'm just going to warn you, they're not always alternating. Okay? But this case, that's an alternate. So which one's my answers? The positives or the negatives? Positives. So what's one interval that's a positive?
Negative.
Why is it positive? Oh, yeah.
Got
Looking
it.
for greater than 0.
Yep.
Good question. You gotta know how you know. Okay, what's the one interval?
-2. Oh,
-5?
negative.
To what?
0?
-5 to 0. So -5,
Oh wait, that's
Because
what we're
it's-
doing efforts, not those things.
it's the whole interval.
Yeah.
To -5 and 0. Okay? And then what's the other one? And they're both parentheses because it's open, right?
It's 2 to infinity.
2 to infinity. Yeah, there you go.
Wow. I'm really hungry.
Me too.
I am
She just-
starving as well. We got 20 minutes. Okay, don't write this down, okay? Let's just play with this for a second. What color should we use to play?
Pink.
Why
Yes,
does everyone say pink?
because it's playful.
Bro.
There we go, pink. Happy?
Very.
What if, hypothetically,
Oh,
what if this was greater than or equal to? How would that change my final answer?
it would make it closed.
It would make what closed?
The everything.
Make everything closed, right? Except for
The infinity.
the infinity, because it's always open. So it would make this a bracket, and this a bracket.
Would it change it any way you do the equation?
Nothing else changes.
Okay.
That's it. Okay? That's the only thing that changes. If this was less than or equal to, how would that change it? Oh, wait a minute, gotta do different colors. That was pink. Okay, pick a different color.
Purple.
I'm not doing purple, it's too dark.
The light
Orange.
purple.
Orange.
Yellow.
Oh, wait, you already do orange.
Okay, let's do yellow. Let's do a pastel yellow. How's that?
Yellow.
That's not really yellow, but we'll
Wow,
go
I'm
with it.
not really good at this.
It's kind of a yellow.
Yeah.
Okay, what if this said less than or equal to? How would that change my answer?
It would make you do the negatives instead of the positives.
So give me the answers. What would it be?
It would be like negative infinity to -5 or 6. Sorry, that
No,
was
no, no, no.
It is
Negative 5.
-5, yep. And would be a bracket or a parenthesis?
Bracket,
Bracket.
and then union with the
You.
0 to 2.
And they would both be bracketed, right?
Yes.
Okay, very good. You got it? Okay, beautiful. So my goal is, I'm gonna have you try one on your own, give an example, and then we're going to change it, and we're gonna add in, what if we have a rational function?
Let's not do that.
That's what last hour said too, then once I showed you, it was like, oh, this is easy. Yes?
Okay, so whenever it says, okay, whenever it's greater than, then you do the positives, when it's less than, you do the negatives?
Yes. And then what about if it's equal to?
If it's,
How does that change it?
oh, greater than or equal to?
Greater than equal to, less than equal to?
Well, it'd be bracket.
It's brackets. Only thing that changes.
That's
Yeah.
me.
Everything else is the same. Okay. Very good. You try this one. All right. What color should we use on this one? I think it's still yellow, right? No, back to blue. You try. Let's go with x squared. Let's go back to a cubic function, and I'll put it in standard form for you. You're welcome.
Thank
Thanks.
you.
Minus 6, let's go less than equal to 0. Okay? Solve that one.